On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at two examples of when you must know the chain rule in order to find a derivative. These two examples here, the only way we can find the derivative is to know the chain rule. In a previous video, we did look at the chain rule of this example, but we also did it the algebraic way, the long way of doing some algebra. Now, I did show you the chain rule back here, but I want to show you an alternative representation of the chain rule. Consider y equals cosine of x. If we find the derivative of this, y prime equals negative sine of x, and that is the derivative of cosine. But what I want you to think about is, suppose we come back and we multiplied by the derivative of x. Well, what is the derivative of this thing here? The derivative of x is just 1. And that's another way we can think about chain rule. Suppose I wrote this as y equals cosine of u, where u can be pretty much anything we want it to be, some other function. Well, the derivative of this is going to be negative sine of u times u prime, whatever that u may be. Let's look at that in this example here. Let's call this entire thing u. That's our function, okay? So when we find the derivative of cosine of u, well, that is going to be y prime equals negative sine of u. Well, that's going to be of this entire thing, so we're leaving it alone. That's what I want you to think about there. And then we're going to come back and we're going to multiply by u prime. We're going to multiply by the derivative of this. The derivative of this is going to be 12x cubed. Notice there, all I'm doing is I'm taking this entire thing that I called u, the thing that I left alone here, we come back and multiply by the derivative of that stuff, which is just going to be 12x cubed. So what I want you to think about is this too. You can look at it like that, but also notice we have like an outside function, which is the cosine, and then we have this 3x to the fourth minus 5 sitting on the inside of that function. So a way you can think about it is this. Take the derivative of the outermost function. Well, the derivative of cosine is negative sine. Leave the inside piece alone, which is what we did right here, and then we come back and multiply by that piece that we just left alone. Rewriting this, we have negative 12x cubed sine of 3x to the fourth minus 5. And that is our derivative for this problem. So now let's explore this one here. Suppose we had y equals the natural log of u. Y prime would be, well, the derivative of natural log is 1 over u, but if we come back and multiply by u prime, that is our chain rule. So this is an alternative form of the chain rule. Therefore, if we apply that, we're taking the natural log, and if we call this stuff right here u, we are really saying the following. S prime of t is equal to, our outermost function is natural log. The derivative of natural log, in this case natural log of u, is going to be 1 over that stuff. So we have 1 over the tangent of t. But then we want to come back and multiply by that stuff, that u that we left alone. Notice it says times u prime. The derivative of tangent of t is secant squared of t. Now, some textbooks will refer to the natural log of u, its derivative. Really, if we just rewrite this as the following, y prime equals u prime over u, that's really what the derivative of natural log of u is when we apply the chain rule. Therefore, we can come back and multiply these two fractions together, and it'll look just like this. S prime of t is going to be equal to the secant squared of t over tangent of t. So all I really did there was just take the 1 times secant squared, which is secant squared t, and then tangent of t times the understood 1 is a tangent of t. So some textbooks will show you the chain rule of natural log. They'll write it like this, u prime over u, where u is the inside function. So there's a couple of ways to think about chain rule here. The one that I mentioned in the intro video, and then I also mentioned here too, thinking about, what's the outside function? Over here it was cosine. We took its derivative, we leave the inside alone, and then we come back and multiply by its derivative. That's exactly what we're doing over here as well. Natural log is our outside function. We take its derivative, 1 over, we leave that inside stuff alone, and then we came back and we multiplied by the derivative of that stuff. And there you have it, 2 examples of applying the chain rule, showing you multiple representations. Back in the intro video, we did go over this form of the chain rule, but it's really doing the same thing as what we're doing here. And I'm trying to show you these alternative representations because when you look in the back of a calculus textbook, you're going to probably see some U's or some F primes and G primes and all that stuff. There's so many ways that we can actually look at the chain rule here, different representations, but hopefully by me exposing you to these different representations, you can kind of get an idea or a feel of what works best for you. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.